Hey guys, sorry I'm absent today, but I wanted to keep you guys up to date and things like that, so we're going to switch up our days. We would normally do the density lab today and then follow up with nomenclature and things like that. So we're going to do more of a lecture kind of practice day today and move that lab to Wednesday. So we're just kind of flip-flopping Tuesday and Wednesday's discussions and activities. So the first thing I want you guys to do is we left off where the practice of reading the graduated cylinders, we did the first two together as a class, but I want you guys to take the time to do the last three as a bell ringer. So pause the video, make sure you guys feel good and comfortable with that. Go ahead and work with your group to discuss to see if you guys have the same answers, and we will go over that on Wednesday. The density lab we're going to do Wednesday as well, so we're skipping over that for right now, and we're going straight into accuracy, precision, and significant figures. So we talked a little bit about this with glassware. The difference between accuracy and precision: accuracy is hitting the exact number, the exact correct value. Precision is being able to replicate that same answer over and over and over again. So we use graduated cylinders and burettes in our glassware because we're able to reproduce that same volume over and over again, as opposed to a beaker or Erlenmeyer flask. To basically calculate our accuracy and things like that, that's why we calculate percent error. We already did our percent error with the bubblegum lab, so you're a little bit familiar with this. What we want to hit on next is significant figures. So significant figures are important to basically be able to do experimental procedures and report data to get our correct answers. There are some chemistry teachers out there that will make you do every single thing in a proper significant figure. My rule of thumb is I want to do what AP College Board does, and they usually only have 1 point that's based upon significant figures for their AP test. So I like to teach significant figures. I like to teach you what it's all about. I like to stress on it periodically, but other than that, we're not going to really care about significant figures that much. Now, if you are actually doing research, if you're doing lab, if you go to college and you take analytical chemistry, that's where it's going to be really important. So basically, there's a whole bunch of rules, and if you look at the slideshow, you will see all of those rules. So there's numbers that are significant versus non-significant. So if you look here, these zeros that are in front of the number here, so we call that a non-zero number, those are not classified as significant. The numbers after the non-zero numbers are significant. Now, all of these rules can get very, very confusing. So what I like to do is I like to have a visual graphic of what's happening here. So what we're going to do is we're going to represent the United States here, and this is way better than me actually drawing it out. Just one moment, let me get my drawing tool here. Okay, so the land of the United States is representing non-zero numbers. So this land here, non-zero numbers, okay? And then a little bit of a geography lesson. The ocean that we have over here is known as the Atlantic. The ocean that we have over here is known as the Pacific. Hopefully you knew that. So what the ocean is representing is your zeros, right? So these are your zeros, these are your zeros, okay? Now, the reason why we're focusing on this being called the Atlantic represents a decimal that is absent. And that helps you determine if those zeros are considered significant or non-significant. So we're going to talk about that in just a second. So Atlantic Ocean, this is representing that a decimal in the number is absent, or P stands for present. So P-R-E-S-E-N-T. All right, so decimal absent versus decimal present. So let's take the first number. Our first number, let's go here, 0.000125. So our goal here is to figure out how many significant figures this number has. So how I analyze this is I ask myself, is a decimal present or is a decimal absent? So is a decimal present or is a decimal absent? So I would evaluate that this decimal is present. So what that tells me to do is I want to go in this direction until I hit a non-zero number. Once I hit that non-zero number, I then count that non-zero number and everything after. Doesn't matter if it's zero or non-zero, okay? So let's model that here. A decimal is present, so that tells me that I've got to enter and find a non-zero number in this direction. So let me use a different marker. I'm entering, I'm entering, I'm entering. I hit my first non-zero number. So what I do from here is I count this number and everything after it. So therefore, this number right here has 3 significant figures. Let's do another example. Let's say we have the number, let's see, 1, 2, 5, 0, 0, 0. All right, now this number, what I'm going to do is first evaluate. Do I have a decimal present or do I have a decimal absent? I do not see a decimal anywhere here. So my game plan is to now enter into the non-zero number in this direction. So do you see that's why it's important for us to know the geography? Here's our non-zero numbers. If a decimal is present, we enter this way. If a decimal is absent, we enter this way. And I promise this is an easy trick that's a lot better than memorizing all of those rules. So for here, decimal absent. So I'm going to enter my number in this direction until I hit a non-zero number. There's my non-zero number, so I count everything that goes beyond that. So this number actually also has 3 significant figures as well. So let's do a couple more examples. Let's see. Here we go. 12.500. Let's count how many significant figures this has. All right. First, evaluate. Do I have a decimal present? So I come in this direction to hit a non-zero number. Or do I have a decimal absent where I'm entering in this direction? A decimal is present, so we're going to enter this direction. And you see how the very first number that I have hit is a non-zero number. So what that means, I count this and everything that comes after. You see, I'm just keep on traveling through, right? So therefore, this particular number has 1, 2, 3, 4, 5, 6 significant figures. Let's do one more. We have 0, I'm gonna write this up here, 0.0200. All right, step 1, analyze. Do I have a decimal present or do I have a decimal absent? I have a decimal present, so that means I'm going to come in this direction until I hit a non-zero number. Once I hit that non-zero number, doesn't matter what comes after it, I'm going to continue counting those as significant figures. So this particular question, or number I should say, has 3 significant figures. Hopefully that little trick makes some sense to you. What you're going to do now with your group is y'all are going to work on this practice. It should be on your worksheet packet. And figure out how many significant figures that you have for each of these here, all right? Let's see. One thing I do want to note, because you might have this question, when I have something in scientific notation, which is when you say times 10 to raise to some power, that scientific notation doesn't mean anything. I'm still just looking at this number here to determine how many significant figures we have. So I would just be looking at 1.04 to determine its significant figures, 7.500 to determine the significant figures and go from there. So remember, non-zero numbers are in the center. If a decimal is present, I go this way. If a decimal is absent, I go this way. Once I hit that non-zero number, I count everything after it. Doesn't matter if it's a zero or not. So hopefully that makes some sense to you guys. I expect this to be done and we'll go over it on Wednesday. What I want to talk about next is rules for calculating with significant figures. So there might be one question that's on the AP exam where you have to do some calculations as well. Now, there is a different rule for calculating when you're multiplying and dividing versus if you are adding or subtracting. So let's go through that. If you are multiplying or dividing, what you do is you look for the fewest sig figs in your number. So you're counting the fewest number of significant figures in your number. You are going to then report your answer to that fewest number of sig figs. So let's go through an example so I'm making sense to you. Let's say we have, this question right here, okay? So we are multiplying. So anytime we multiply or divide, what we do is we step one, count the number of sig figs for each thing, all right? So 18.2, decimal is present, so we go this direction. We count once we hit that non-zero number, everything after. So this one would have 3 significant figures. For this number here, decimal is present, so we go in this direction. We hit our non-zero number. We count everything after. So therefore, this has 4 significant figures. So what I'm going to do next is I'm going to calculate 18.2 times 1.998. Give me 1 second. Let me grab my key. I got to get where you guys are at on here. So when I calculate those two values, I'm struggling. Un momento, por favor. Nope, not it. Here we go. This is the answer that I get. 36.4 blah, 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 36 point something, right? Now, when I report my answer, I want to look to see which one of these has the fewest number of sig figs. Obviously, 3 is the fewest compared to 4. So when I report my answer, I want to round and report to 3 sig figs. So my answer that I'm going to record for this is 36.4 because that is 1, 2, 3 sig figs. If I do this one here, 10.2 divided by 1.34. This one has 1, 2, 3 sig figs. This one also has 1, 2, 3 sig figs. So therefore, when I get my answer, I need to have it reported in 3 sig figs also. So this is the process you do whenever you are multiplying or dividing. Now, if you are adding or subtracting, you look at something a little bit different. You look at not sig figs, but you look at decimal places. So when you're adding and subtracting, sig figs out, decimal places is what we look at. So we always want to report to the fewest number of decimal places. So let's look at this number here. You see how our mathematical function is adding. So when we add or subtract, we look at decimal places. So this, remember decimal places are what's behind the decimal, has 2 decimal places versus this one has 1 decimal place. Do y'all see how I represent decimal places? It's different from significant figures. So what I do is I evaluate who is the smallest amount of decimal places. That is 1 decimal place. So when I do my math here, my answer is going to have 1 decimal place only. So that is the rule if we're adding or even subtracting numbers. Hopefully that makes a little sense to you guys. So what you are going to do to practice that, I believe this is on your practice as well. You have your values here that you are going to practice the mathematical functions with. Now, I also want you to report your units. So just like we did when we were doing the graphical analysis where we had our slope was grams over cubic centimeters, I want you to work with your units here as well, because this is a skill that you're going to need as you're working through stuff in AP Chemistry. So if I say my answer, I also want to report the correct units. So for this first one, my answer I divide, I report to the correct number of significant figures. The reason why we're working with significant figures is because our function mathematically is dividing. So multiply and divide, significant figures, add or subtract, just decimal places. Once we divide these two numbers and report to our correct amount of significant figures, we also need to report our units as well. So this would be grams divided by liters. Sorry, I didn't mean to slide, advance my slide. So grams divided by liters would be our units there. So I want you to work with and tackle those units. Again, we're going to go over this stuff on Wednesday when I'm here to make sure that you guys aren't lost, okay? So that's all I got for significant figures. I'm going to do a separate video to help you guys with the nomenclature since this video is already a little bit lengthy. So the next thing you guys are going to do is tackle some nomenclature practice, and we'll get to that in the next video. Have a good one.